Okay, so in this video, we are going to discuss limiting reactant. So limiting reactant is a specific type of reaction stoichiometry where when you have two or more different reactants going into a process, odds are you're going to run out, right? Run out of one of the reactants before the other. And at that point, the reaction is going to stop because I don't have the two things that I need, right? I have to have both components in order for my reaction to occur. So if I run out of one, I cannot perform the reaction anymore. So the one that you run out of limits the amount of product that you can make. So we call it the limiting reactant, right? It's the thing that limits how much product. So let's look at an analogy, and this kind of will make this make a little bit more sense. So to make a batch of brownies, right, a 9x13 standard pan of brownies, I need a box of mix and 3 eggs and a half a cup of oil, right? Those are the ingredients. And I have to have all 3 of them in that proportion in order to make 1 pan of delicious brownies. So if I go into my kitchen and I take inventory of my ingredients and I have 3 boxes of mix and 5 eggs and 8 cups of oil, how many batches of brownies can I actually make, right? Well, let's look at them individually. I have enough boxes of mix to make 3 batches because 1 batch requires a box. I have 3 boxes. I have 5 eggs. Well, each batch requires 3 eggs, so I only have enough eggs to make 1 batch. I'll have 2 eggs left over, but the 2 eggs don't make anything, right? And 8 cups of oil. Well, I only need a half a cup, so I really have enough oil to make 16 batches. So if I look at the ingredients all together, the thing that's going to limit the number of batches I can make is the eggs, right? Because I only have enough eggs to make 1 batch. So how many batches can I make? I can make 1. Why? Because I run out of eggs, right? The eggs are the limiting reactant. They're the thing that determines how many batches of brownies I can make because it's the thing that I don't have enough of, right? It's the thing that I just ran out of. So when we're looking at these reactions, you need to think, well, who are my eggs? What am I running out of? What is going to cause me to make the least amount of something? And that's going to be my limiting reactant. So there's 2 types of limiting reactants problems that you're going to see. The first type is where it asks me just to identify the limiting reactant, right? So kind of like what I did with the eggs. Who do I not have enough of? Well, I don't have enough of eggs. What is the substance? The second one is going to ask me to determine the amount of product I can make from different amounts of reactants. So I'm asking for a numerical answer. So this would be an identity answer versus a numerical answer. So we're going to do one example of each, which will be sufficient because it's the same method of stoichiometry that we've been doing. You're just going to be talking about it in terms of 2 starting reactants. All right, so let's look at our first example. All right, what is the limiting reactant if 50.0 grams of magnesium and 75 grams of hydrochloric acid react? So it's asking for the limiting reactant, which means it just wants to know, who is my eggs? Who's going to cause me to make less? Is it the magnesium or is it the hydrochloric acid? Now, it is not as simple of going, well, I have less magnesium because I don't know what my ingredient list is. I don't know how much magnesium I need to react with hydrochloric acid. So to figure that out, the first thing I have to do is balance my equation. So I know that hydrogen is diatomic. And this is actually going to be hydrogen gas. And so if I have 2 hydrogens and 2 chlorines, I'm going to need 2 hydrochloric acids. Okay? So a couple things to keep in mind. When you are only asked to identify the limiting reactant, you have some wiggle room in your procedure. Because I have 2 products here, and it doesn't matter which one I choose to solve for, but I have to be consistent, which means if I'm going to take the magnesium and solve for magnesium chloride, I better solve the hydrochloric acid for magnesium chloride as well. because I have to be able to compare my results, right? I have to be able to say it's going to make this much magnesium chloride versus this much magnesium chloride. Apples and apples, right? If I take one to magnesium chloride and one to hydrogen gas, I don't have apples and apples, right? I have apples and oranges. So I have to take them to the same thing. It doesn't matter which one I choose, just be consistent. And then also, I can solve in any unit. I can solve in moles, I can solve in grams, I can solve in liters, I can solve in molecules or atoms or formula units. It does not matter. I just have to be consistent. But think about it in terms of how much math you have to do. Solving in moles is going to be the easiest because I don't have to convert out after I mole bridge. If you don't want to look at it in moles, if you're worried that moles is going to be too small of a number, go to liters, right? Multiplying by 22.4, nice, easy constant. I'm not having to calculate molar mass, and typing in Avogadro's number is just a pain. Okay, so be smart. Make the math easy. All right, so in order to set this up, I'm going to pick one of my two products. Again, it doesn't matter which product. I'm going to pick the H2. You could just as easily pick the MgCl2. I'm just choosing to pick the H2 because it's less to write. So I'm going to take both of my starting amounts and I'm going to solve for moles of H2. Now again, I could go to any unit, but I'm going to go to moles of H2 because it requires the least amount of math. All right, so 50.0 grams of Mg times 1 mole Mg over the molar mass of magnesium, 24.31 grams of Mg times, now I need to mole bridge, 1 mole H2 over 1 mole Mg. So 50.0 divided by 24.31. 2.06 moles of H2. Okay. So I'm not done. I have to do the hydrochloric acid now so I can compare. So 75 grams HClAq times 1 mole HClAq over 36.458 is the molar mass of hydrochloric acid, times 1 mole H2. Remember, I have to go to the same thing over 2 moles HCl from our balanced equation. Okay. So now 75 divided by 36.458 times 2. What do I get? 1.03 moles H2. All right, so now I need to compare. Remember, the one that is the limiting reagent is the one that allows me to make the least amount. So when I react both of these, 75 grams of hydrochloric acid allows me to make 1.03 moles of H2. 50 grams of magnesium allows me to make 2.06 moles of H2. I cannot make 2.06 moles of H2 when I'm going to run out of hydrochloric acid when I hit 1.03. Because remember, both of these things have to react together in this reaction. So I'm going to run out of the hydrochloric acid when I've only made 1.03 moles. So when I look at what is the identity of the limiting reactant, it's the one that allows me to make the least. So HCl limits. And then I'm going to put the number over here in parentheses just kind of to back that up. How did I figure it out? I know how much I can make. If I had gone to magnesium chloride, right, I may have generated different numbers, but this would still be less than this because whatever is limiting regardless of which of the two products I go to. All right, so it is impossible to make 2.06 moles of H2 because I'm going to run out of HCl once 0.0103 moles of H2 forms, and then I just have extra of this. So ask yourself this question. If I did mix 50 grams of magnesium with 75 grams of hydrochloric acid, when my reaction stops, what's in my reaction vessel? What have I made? Well, I've obviously made my two products. I've made magnesium chloride and I've made hydrogen gas. So those are in my vessel. But think about your reactants. If I had enough magnesium to make 2.06, would I not have some unreacted magnesium left, right? I used all of this, right? Plum ran out, but I have extra magnesium. So I would say that I've got magnesium chloride and H2 as products and excess or extra Mg remaining. It's unreacted, right? It's the excess reagent. It's the thing that I have too much of. I don't have anything left to react with. And that's kind of a conceptual question that you should be thinking about with these limiting reactants problems. All right, so that's the first way. If I say, okay, just what is the limiting reactant? The second way is if I specifically ask you to solve for a numerical value. So let's look at that one. How many grams of NH3 can be made if 28 grams of N2 and 25 grams of H2 react? So I have two starting points again, but this time it specifically says, this is what I want you to solve for. You need to solve for grams of NH3. It doesn't come right out and ask you for a limiting reactants answer, but you should know that because you have two different starting reactants. All right, so let's balance our equation. So diatomic, 2 here, 3 here. All right. So it tells you what to solve for. You know it's limiting reactant, again, because you have two different starting values. You're going to solve both values given for the same thing, and then you compare. And remember that you're going to get two numbers, but you can only make the smaller one because that's when you run out of that reactant. And for the love of God, don't add them together, right? If I can only make the smaller one, I certainly can't make both of them. All right, so let's take our 28 grams of N2 times 1 mole N2 over 28.02 grams N2 times, I'm going to NH3, 2 moles NH3 over 1 mole N2 times the mass of NH3, 17.034 grams NH3 over 1 mole NH3. So my grams cancel, my moles cancel, my moles cancel, leaves me in grams. So let's look at how many grams that is. So 28 times 2 times 17.034 divided by 28.02. 34.0437. I'm going to write down more digits than I need because sometimes these are really close and I don't have to type back into my calculator. I can sig fig at the end once I figure out which one's my answer. All right, so now let's do the other one. So I have 25 grams of H2 times 1 mole H2 over 2.016 grams H2 times 2 moles NH3 over 3 moles H2 times 17.034 grams NH3 over 1 mole NH3. All right, so let's do that one. 25 times 2 times 17.034 divided by 2.016 times 3. Ooh, 140.8. Okay, so let's look at our answers. The 28 grams of nitrogen will allow us to make 34 grams of NH3. The 25 grams of hydrogen will allow me to make 140. I can't make 140 because I'm going to run out of N2 once I hit 34 grams. So my answer to 2 sig figs is 34 grams NH3 N2 limits. Okay, this is the smaller amount. That is what I can make. I cannot make this. I will run out. All right, so all of your limiting reactants problems are going to be one of those two ways. Either what is the limiting reactant? So do two problems, pick the smaller number, and what gave you the smaller number is your answer. Or specifically solve for something, and then whichever one is the smaller number generated is your answer. Those are the only two types you can see.